Alright, part 3, project preparation, question 3 here. How can we get the spiral squares to switch direction? If we look back in the original problem here, it says the value q equals 0.2 and p equals 1 minus q equals 0.8 was used to divide each edge into two parts with ratio p to q. And you can see this in the triangles program. But the interesting pattern of figure 1.11, which figure 1.11 is this, was obtained by reversing the roles of p and q in half of the squares. Half of the normal squares, which is similar to black and white of a normal chessboard. So half the squares have our original ratio of p to q, and half of them have those ratios reversed. So if we go back and look at our original inner triangle, what they're talking about is here the ratio of this length to this length is q, this is q, this is p, right? And this is q, this is p. So if we reversed the values of q and p, then this vertex, this A1 vertex, would move to over here, right? Because we would have this length for q, and then this littler, this length that used to be q, that would be over here, right? So let's take a look at, maybe it'll be clearer if I show it. So right now, I'm going back now to our project from part 1 with the CV square spiral. Let me just run this one real quick. So we have a square, and this is length q, this is length p, okay? This is length q, this is length p, or they're in the ratio, right, of q to p, and so on. Okay, so we want to reverse it. If we switch and make q be the long bit and make p be the short bit, and we can do that pretty easily. I'll put it, actually, I think it's easiest if I show it in this constructor here. If we say instead, so now we've set up our p and q, right? If we reverse those guys, let's say this, this q equals, let's say equals p, and then this p equals, again, I'm going to say 1 minus q, right? Because if I, what's the telling me here? Oh, the variable might have already been assigned, yeah. So this, so maybe the easiest way to do this, because I forgot those are final. So maybe the easiest way to do this is like this. We'll get rid of that, and we'll say this p equals q. Okay, so I'm going to say p is equal to q, and then q equals 1 minus p. How about that? Okay, so now, see, we're reversing the roles then. P gets what was passed in as q, and q gets what's passed in as p, and that should reverse the direction. And yoink. Okay, let's make sure we see that it's going the other way. So here, remember, here's the long bit, so it's curling this way. Maybe I can even keep this one up so I can compare it. And comment this out. Now let's run the original one and just see for comparison. Okay, so here's our original, and here's the one we made by reversing p and q. Okay, so that's what we're going to need to do is alternate, the values of P and Q like that. And we also know, get rid of this. We also know that in our checkerboard here, we know how to alternate colors, right? Where is that? Yeah. So right here, we alternate colors. So we'll use this same. We'll use this test here to decide which way we're going to flip or how we're going to handle our values, alternate our values of P and Q.